Hi everyone, it's Dr. Shannon from the Abrams Planetarium back with another video for the Grand Ledge Area District Libraries. This time we're going to be talking about the winter sky. So we're going to take a look at what constellations you can see in the winter and where you can find different planets for this year during this winter. And we will be using Stellarium from stellarium.org. This is a free software that you can download for your computer, or they also have a web-based version. So you go ahead and go to stellarium.org if you want to go ahead and check out the same software that I am using for this video. And let's head over and actually look at the sky. Now, the winter is one of my favorite times to go outside. It is really cold. It's not very clear in Michigan, but when it is clear, that cold air actually makes it very still. It's not moving around a lot, which makes it a really nice time to go and look at the stars without a lot of twinkling and just appreciate them. And also, some of my favorite constellations are up during this time. But we're going to start by looking at the planets. So I have us set to Lansing, right in the middle of Lansing, on January 11th, 2021, which is the day that you might be watching this, the day that this will be first airing for Grand Ledge Area District Library. And I wanted to start here because I wanted to show you some of the planets that are up. So I have us set to 6 p.m., so you can see that down here. And it might seem weird because I have some cactuses and then other types of trees. This is from our sky calendar panorama that we offer from the Abrams Planetarium. And we set it to work with anywhere within most of the northern hemisphere, which includes climates that have cacti and different types of trees. So it seems a little strange, but that is why we have that. Okay, so let's go ahead over towards the west. So we are at 6 p.m. The sun has just set. And if we look towards the southwest, even as the sun is setting, you might be able to get a nice peek at a few different planets in mid-January. So you would need a very clear view of the southwestern horizon. So get to the top of a parking structure, a big open field. They will be very low in the sky, but you might still be able to get a quick peek at Jupiter. Saturn might be really difficult. You might need some binoculars to see Saturn. But if you saw the Great Conjunction, or at least one day on either side, Michigan was very cloudy on the day of the actual conjunction. But we started off the end of 2020 with Saturn to the upper left of Jupiter, and now they've passed each other with Saturn to the lower right of Jupiter. So we'll see them come together again in about 20 years. But you can also see that just to the lower left of Jupiter, you can start to see Mercury. So Mercury is one of our inner planets, so it's closer to the sun than we are. So we're always looking towards the sun to see it. We'll always see Mercury either right after the sun sets in the west or right before the sun rises in the east. And in mid-January, we start with Mercury being in the west at sunset near Jupiter and Saturn. Again, they're very low in the sky, so they're going to be hard to see. But let's go ahead and skip forward in time just a little bit. As we move through the rest of January, we're going to see Jupiter and Saturn disappear into the glare of the sun and below the horizon. But Mercury will get higher and higher above the horizon, but it is still pretty faint and difficult to see, so you might again need binoculars in order to see that. And then by the time we get to the end of January, we'll see that Mercury is quite difficult to see, so maybe we'll go just a tad later to about 6:15, and you will be able to see Mercury again. So you have to, as the sun sets later and later as we go through winter, you'll have to go out just a little bit later to see Mercury. But as we go through, you will be able to see Mercury, but eventually Mercury will fade from view as well. And then by early February, we will not really be able to see Mercury. It's going to be back to being close to the sun, so it got farthest away from the sun, and now it's getting close to the sun again from our perspective, and so we won't be able to see it for a little while at the beginning of February. So now that we're in the beginning of February, sort of like right in the middle of winter here, Let's go ahead and move a little bit later and turn towards the north. So a little bit later where it's a little bit darker in the sky, let's head to maybe 8:30. Here we are. So if we look in the north, we can see our Big Dipper again. So see if you can find that Big Dipper, so our big square spoon in the sky. If you've seen any of the earlier videos, you might notice that it's shifted a bit. So in fall, we saw the Big Dipper over here low in the sky in the northwest. But as we go into midwinter, we find that it's now low in the sky, but in the northeast. So here's our Big Dipper. So there's our bowl and the 3 stars of the handle, which is a part of the official constellation of Ursa Major, or the Big Bear. So there's our Big Bear. The bear's legs are here, the bear's nose, and the tail. But the Big Dipper is the shape that's most easily recognizable in this constellation. And it's very useful because these outer 2 stars of the Big Dipper, if we follow them this way, we find our North Star, which is the end of the handle of the Little Dipper. So there's our Little Dipper always pours into the Big Dipper. So the Little Dipper is very faint. Generally, we can only see the North Star and then the outer 2 bowl stars in most cities. But if you're in a dark enough sky away from the city lights, you would be able to see more and more of these other constellations. Now, if we go from the Big Dipper's handle to the North Star in about the same distance again, we find this M shape or W shape, and that is the constellation of Cassiopeia. Always on the opposite side of the North Star from the Big Dipper, and they go around in circles throughout the year. So by the time we get to spring, we will see the Big Dipper here, high in the northeast. By summer, we'll see the Big Dipper where Cassiopeia is now. And Cassiopeia will always be on the opposite side. So now that we have our north figured out with our lovely constellations, let's go ahead and turn around. And we'll see that Mars is in the south. So Mars is very nice and high in the south right now. So this is in February. Mars is more to the southwest. In early January, if we go back to January 1st, you can see it's a little bit more towards the south. But on February 1st, it's in the southwest at around 8:30 at night. So Mars is going to appear like a rather bright orangish star, just like we see here. Mars is known as the red planet. Let's go ahead and take a closer look here. Because of the rust that's on its surface. And that does come through in what we see with Mars. So if you have a telescope or binoculars, you might be able to take a look at Mars and get maybe start seeing some of the features, maybe the darker regions or the polar ice caps if you've got one. But for the most part, most small telescopes and binoculars aren't going to give you this much detail. But this is a nice close look at Mars. So we do have our lovely red planet that has a lot of rust in its soil, and that is why it looks red. And that red will come through when you look at it naked eye in the sky. So we do have a lovely Mars right there. You can also see there's Uranus near Mars right here. Uranus is not a naked eye planet. You have to use a telescope or binoculars to see it. So you might want to try to, again, with binoculars or a telescope, you might be able to take a peek at Uranus just to the south, a little bit lower and to the right, a little more southwest than Mars. And there are some lovely charts that you can find that will help you try to find Uranus. But do not expect to go outside and see Uranus without a telescope or binoculars. Mars, Venus, Jupiter, Saturn, Mercury, those planets are naked eye. We've known about them since antiquity. Humans have been looking at them and observing them for thousands of years. But Uranus wasn't discovered until 1750, Neptune about another 100 years later, and then Pluto was discovered another 70 years later after that. Or 80 years later. So those all required telescopes to see. Now you would also see that near Mars there's these 2 brighter stars here, and these mark Aries the Ram. So Aries the Ram is marked by these 2 bright stars, Hamal and Sheraton. but there's a few other fainter stars that you can connect in to find Aries. But as we look in the south, in the midwinter around February 1st, we start to see our lovely winter constellations. They're starting to come up now, and we can see them very nicely in early January as well. They'll just be a little bit more towards the east at the same time. But here on February 1st, midwinter, just look towards the south and you will start seeing your constellations. So probably one of the most famous winter constellations, one of the easiest to find, is the constellation of Orion, the Hunter. And see if you can find Orion's belt of 3 stars in a row. That's one of its most defining features. All right, did you find it? Right here. So these are the 3 stars that make up Orion's belt. Here's Orion's shoulders right here and Orion's feet. The constellation of Orion is also known as the Winter Maker by the Ojibwe people, because when you start seeing Orion, that is the sign that winter is here and you must get ready for the cold weather. So here we have the 3 stars. And the stars are named Al-Natak, Al-Nalam, and Mintaka. And so these all come from Arabic words for belt, because this is Orion's belt. And we see we have a bright reddish star that is the shoulder of Orion. This is the star Betelgeuse or Betelgeuse. And it comes from a phrase in Arabic that means the arm or the armpit of the giant, depending on who you ask. And then we have Rigel, which also comes from an Arabic phrase for foot of the giant. So these were Arabic translations of the Greek names for these stars, and then those Arabic translations have stuck as the proper names for the stars themselves. So we have Betelgeuse and we have Rigel, a very bright reddish star and a bright bluish star. So see if you can see that color difference in the sky when you go see Orion. Next, we have the star Bellatrix, which is the other star, shoulder star of Orion. Might sound familiar, Bellatrix Lestrange, as in Harry Potter, a Harry Potter character. And then we have Saiph or Saif, which is the other foot here. And Orion is a really nice constellation in the wintertime because it's nice and bright. Those 3 stars make it really easy to spot in the sky. And we can use Orion to help us find all the other winter constellations. But the reason why I really like this constellation is because we can see the entire stellar life cycle happening in one constellation. So when stars are born, they start off as big clouds of gas and something disturbs it so that it can't really hold itself up against gravity anymore, and it starts to collapse down. And as it collapses and gets denser and denser, the temperature starts to go up, and eventually it collapses down enough that the temperature in the core is hot enough to take hydrogen atoms, smash them together hard enough to turn them into helium atoms, and that process releases light, and then that light is what holds the star up with a pressure outwards against gravity, so it's now stable. It's in a state called hydrostatic equilibrium. So you have gravity pulling the star in, you have the pressure from the light creation going outwards, and that holds it up against gravity. And we can see that process happening in Orion's sword. So here's Orion's belt, and then we have 3 more stars vertical underneath, which are the sword of Orion. And if you look, this middle one is actually quite fuzzy, and that's because this is the Orion Nebula. And so this is a big nebula where there's lots of pockets of gas that are collapsing to make lots of new stars. This is like a stellar nursery where we can really see how stars are forming right here in Orion, in the Orion Nebula. So these are some really bright new baby stars that are really bright, and they're carving out these caverns here, but then there's other pockets that are collapsing to make more stars. So eventually, again, they start burning that hydrogen into helium, and that's what stars do for 90% of their lives. And that's what all these other stars in Orion are doing pretty much. They're just chilling out, making their hydrogen into helium in their core and being a star. But then eventually they run out of fuel. And when they run out of fuel, they can't hold themselves up against gravity. So they start to contract. And then it gets hotter and hotter in other regions of the star, which then get hot enough to start burning hydrogen into helium. But sometimes it's too much energy and actually causes the star to puff up because it's sending out more pressure than it needs just to hold itself up against gravity. And we get a red giant star. And that's what Betelgeuse is. That's why it's so red. So we have Betelgeuse as a red giant star. So this is a star ending its near the end of its life. One day, this particular star, it's large enough. Not all stars do this, but large stars do. It will actually explode as a supernova. And that's what's really exciting. And so Betelgeuse will do that one day. And when it does, it'll be bright enough to see with naked eye during the day. We don't expect this to happen for another 100,000 years or so. But Betelgeuse gave us quite some excitement in the past year. We actually saw it dim quite a bit. It actually got to be just as bright as Bellatrix over here, which is quite a big dimming for this star. We didn't know what was happening at first, so some people thought it was about ready to explode. It did not. It seems that it sort of coughed up a big chunk of gas that cooled quickly and became dark dust that blocked out some of the light, and then it traveled away, and now Betelgeuse was getting brighter again, and now it seems to be dimming. It's a really interesting and active star, so it's one to keep an eye on for sure. All right, so there's Orion. That's why it's one of my favorite constellations, is there's so much going on there with the stars. But we can use Orion now to help us find the other winter constellations. So Orion's belt, if you follow it downwards, we find this very bright star called Sirius. And Sirius is the brightest star in the night sky. Not the brightest star in our sky, that would go to the sun. But in our night sky, Sirius is the brightest star. And Sirius is part of Canis Major, which is one of Orion's hunting dogs. So this is the large dog. Now here we have our dog. This little triangle of fainter stars marks the head. Sirius is on the collar and the legs and the back and the tail here. This one actually kind of looks like what it is. It is our dog. And if you do read Harry Potter, Sirius Black, spelled the same way here. He also turns into a dog in the stories. He is an animagus, so he can turn into a dog, into an animal. So there is some connections here to the Harry Potter stories. Sirius is also, again, a very, very bright star, and it's called the dog star. And in the wintertime, we see it over in the southeast at nighttime. But in the summertime, in August, during some of the hottest times of the month, we actually see Sirius rising in the southeast just before the sun does. And because it's so bright, some people thought that what was happening was that Sirius and the sun were combining their energy, and that's what made it so hot. That's not what's actually happening. We understand that Sirius is much too far to really give us any real heat, but that's what some people thought a couple thousand years ago, and that this is where the phrase dog days of summer comes from. It's because Sirius, the dog star, is near the sun at that time. All right, so this is Canis Major, our large dog. So we also have a small dog. So let's go find Orion's small hunting dog. And we can find that using Orion's bright star Betelgeuse, Sirius, and we find this other bright star here called Procyon. And together they make our winter triangle. And Procyon is the brightest star in Canis Minor. Now I'm going to connect all the stars in Canis Minor. Let's go. Ta-da! It's two whole stars. This constellation is just a line. So we like to call it the hot dog at the planetarium. So there we go. We have our constellation that actually looks like a dog and our constellation that looks like a hot dog. These are Orion's hunting dogs. Now we can use Orion's belt and follow it upwards, and we find, like this little V shape of stars here with another bright reddish star. This is another red giant star like Betelgeuse, and it's called Aldebaran. And we can extend this up here to make a very large V shape, and then follow these stars downwards to make a Y shape. And we now have the constellation of Taurus the Bull. So these are the horns of the bull, and this is the face right here. This is the bull's chest and the bull's back. Here, let's actually turn some art on to see that. So we've got Orion, our hunter, the two dogs. We have Taurus the bull and Aries the ram back here. Now, you can see that there's another line connecting out here, which connects to this cluster of stars. So this star here you can see is called Aldebaran. And Aldebaran comes from an Arabic phrase for the follower because it appears to follow this cluster of stars here. Let's take a closer look at this cluster. This is called the Pleiades, or the Pleiades star cluster. It's also called the Seven Brothers, the Seven Sisters. It's known as Subaru in Japan, so this is the Subaru car company's logo. But this is an open cluster of stars. So there's two types of star clusters. Open clusters, which are more within the plane of the disk of the galaxy. They tend to have hundreds of thousands of stars, and they're really quite pretty to look at. Globular clusters, they're a lot more dense. They can have 1 million stars or so, and they live farther away from the center of our galaxy, and so they're a little bit harder to see. Open clusters also tend to be much younger. Globular clusters tend to be very, very old, like billions of years old. So this is the open cluster of the Pleiades. It's quite, you can see about 6 stars naked eye, sometimes 7. The name 7 or the number 7 is often associated with it, but there's also various stories that talk about there being 7 brothers or 7 women or 7 men, and then one of them disappears. So maybe there was a star that, a 7th star that was very easily seen that has since died. But this is a really nice, beautiful cluster that you can go outside and see naked eye. Now, as we zoom in here, we can also see that the V shape of Taurus has a lot of these, a lot of stars. So this is actually another open cluster here that makes up the face of the bull called the Hyades cluster. So we have the Hyades and the Pleiades here. And if you look at the Pleiades with binoculars or a telescope, you'll be able to see more and more of these smaller stars within the cluster. So go check that out, but even if not, it's a really beautiful thing to see. You might notice it first out of the corner of your eye with averted vision. Anything that's sort of more spread out is going to be easier to see out of the corner of your eye. Okay. So let's go back to our full sky here. We have Orion and our dogs again. So we used Orion to go upwards to find Taurus the bull and the Pleiades. Now here we can follow the horn to the brighter star, the brighter horn star of the Taurus the bull. And here we have this sort of house shape, and Taurus shares a star with this. Also has this fainter star up here that often gets connected. Stellarium doesn't connect it, but you can imagine there's another one right there. But we have this very bright star here called Capella, and then this little triangle, small triangle of stars here, which we call the kids. So Capella comes from the Latin word capra, which means goat. So this is known as the mother goat star. And then here, these 3 stars are called the kids. So these are her baby goats. And when we connect them, they're part of they're part of this larger constellation called Auriga, which is the charioteer or the chariot driver. And again, you can kind of imagine another star right here. And so let's look at the art for this. So the art shows a chariot driver. He's holding broken reins, and a goat and her kids. This one only has 2. Most art depictions show the 3 for the 3 kids here. But we think that these might have been 2 separate constellations, and over time they kind of merged together to make the chariot driver holding the goat. So it's a really interesting constellation. Doesn't look anything like what it is, but we have the mother goat, her kids, and then the rest of the constellation being that chariot driver. Okay. And the last winter constellation we have, we take Orion's foot of Rigel, that nice bright blue star. we follow it up to Betelgeuse and then continue that line onwards, we find these two bright stars here. They're called Castor and Pollux, and they connect to make the twins of Gemini here. So these it looks kind of like two people holding hands because it is twins. They're the twin brothers of Castor and Pollux. And if you forget which star is which is very easy to do, Castor is closer to Capella, so the two stars that start with C, and Pollux is closer to the star Procyon, also starts with P. And so these are the twins of Gemini. Now their story is really interesting because it's really one that connects their position within the sky. So in the Greek and Roman stories, the twins of Gemini, Castor and Pollux, were twins, but one was, they were both born to a mortal mother, but one, his father was Zeus, and one had a father who was mortal as well. So one twin was immortal and one twin was mortal. And they liked to go on adventures together, and one day the mortal twin died, and his brother was so upset by this, and he went to the gods, and he said, "Can you please make my brother immortal so that I can be with him all the time? I really miss him a lot." And so they agreed, but the agreement was that they would be placed in the sky together, and they would spend half of their time in the heavens, where the immortal twin was supposed to be, and then the rest of the year they would spend their time below the horizon in the underworld, where the mortal twin was supposed to be. So when we think about the stories of the constellations, it's one thing to keep in mind is see how it connects to the stars themselves and the observations of how they move across the sky, where they are, when we see them, how long we see them. Those observations are baked into the stories. The stories aren't just stories. They are ways of conveying scientific observations of what's up in the sky. So those are our lovely winter constellations. Now, in the middle of winter, that means our winter constellations are most prominent in the south after the sun sets. But we can still see other constellations. We do still see a fall constellation in the west, namely Pegasus, the flying horse. You can see the great square of Pegasus. His head is now below the horizon, but you can still see the great square. And you can still see the hero Perseus right here. Here we go. But we also start to see a sneak peek at some of the spring constellations, namely by early February, we start to see Leo popping above the horizon. So we have Leo the lion over in the east. And as we move into spring, we'll see Leo more and more in the south, the winter constellations in the west, and they're constantly shifting as we orbit around the sun. So those are all of our winter constellations. You can just see that when we look in the south, just without any other things on, no labels except for a couple of things, you can see how many bright stars there are in the winter time. The winter has one of the best skies with how many bright stars it has. So that's why I really like going outside to seeing it. And if we take the brightest stars from each constellation, so Capella, we can go down to Aldebaran, Rigel, Sirius, Procyon, and Castor and Pollux, we can make a circle or a hexagon, depending on how you connect it. And we call this the winter circle or the winter hexagon, with Betelgeuse more or less in the middle of that. And so this is one thing that you can go outside and try to find first, is that nice big circle of bright stars in the winter time. So let's look towards the east now. Because it's not just about the night sky, it's also the morning sky, the sky before the sun comes up. So we're going to go ahead and skip ahead hour by hour. And right before the sun comes up, we're going to go back to about 7 a.m. now. I wanted to show you what we can see over in the east. So this is in early February right here. We don't see a whole lot. But as we go through the months, now I'm skipping ahead day by day, we start to see something familiar come up. So remember, we started this by looking on January 11th, and we could see Mercury, Jupiter, and Saturn in the west after the sun sets. And by the end of February, we can actually see them now in the east right before the sun rises. Let's go ahead and go a little bit earlier to about 6:30. So it's a little bit darker. There we go. So by the end of February at about 6:30 in the morning, again, very low on the horizon, so you need a very clear view now of the southeast. But at the end of February, you'll see Jupiter, Saturn, and Mercury now over in the east, reappearing in our sky. And so they're now on the opposite side of the sun from our perspective, and we see them reappear. And then as we go through March, they'll be a bit easier to see right before sunrise, but then you'll have to go out a little bit earlier as we go through the rest of winter, which will go until about March 21st on the first day of spring. So those are some lovely things that you can go outside and see this winter time in terms of constellations and planets. And if nothing else, any night that it's clear, just go outside and marvel at the beauty of the sky and see what patterns you can see. So I hope you guys learned something from that, and I hope you had a lot of fun. And we will see you again in a little while with some more astronomy as we go into the spring. So enjoy and go enjoy the night sky. Bye-bye.